Hello and good afternoon. I'm Callan Fisher, and today we're going to be talking about C++14 and the relaxing of the requirements for the constant expression functions. As I said, I'm Callan Fisher. This is Mark Simpson and my other partner, Michelle Bray.
So previously in C++11, which was the update prior to C++14, constant expression functions, which are executed at compile time, were rather restrictive. They could only contain a single expression. The update to C++14 relaxes restrictions for constant expressions. It also allows variable mutation, and it adds additional restrictions for static and local thread variables. However, things are still executed at compile time. So although the update to C++14 seems relatively minor, Bjarne Stroustrup, who was one of the major players in the creation of C++, actually hopes that it'll be a continuation from C++11. So in particular, our group decided to focus on proposal N3597, which aims to relax restrictions on constant expression functions. This is accomplished through the four following major changes. The first being that you can now declare a variable that is not static or local thread. The second and third being that you can now use else statements and for loops because you can pass in multiple variables. And the fourth being that objects whose lifetime began within the evaluation can mutate.
In C++11, the old definition for constant expression functions were very restrictive, and they only allowed the following statements: null statements, static assertion declaration, type definitions, using declarations, using directions, and only allowed one return statement. In C++14, they really relaxed these restrictions for constant expression functions, because in C++11, it says what it can only contain, while in C++14, it says what it can't contain. This makes it a lot more flexible and shortens the list for all these variables. As you can see in the following code example, C++14 is a lot more relaxed than C++11 with constant expression functions. In the first chunk of code, C++11 would not allow you to increment a variable within the body of a function. However, in C++14, you are allowed to. Also, in the second chunk of code, in C++11, you could not declare a variable within the body of a function. However, in C++14, you can now. This makes it a lot more relaxed, and it allows you to pass multiple variables into one expression.
The constant expression function can now handle multiple variables in C++14. This includes if, else, and for loops. Now that the constant expressions can handle multiple variables or values, it is possible to change objects within the constant expressions known as object mutations. In more detail, object mutation refers to objects that can be modified within the evaluation of a constant expression. This will occur until the evaluation of a constant expression ends, or the lifetime of the object ends. However, mutable objects cannot be modified by later constant expression evaluation. Richard Smith, another contributor to the C++14 update, defines a constant expression function in C++11 as a PR value core constant expression of a literal type, but not a pointer type. There are two parts to the C++14 definition. The first being a reference constant expression is either a GO value or a PR value. The second is an address constant expression is a PR value of type standard null pointer or of pointer type.
Well, the main goal of this update was to relax the restrictions on the constant expression functions. This led to increased restrictions on static and local variables that could be passed. The reason for this is so that there is no side effects at the termination of the program. So while keeping these restrictions in mind while looking at the next block of code, you see that static or local variables cannot be set equal to other variables. Otherwise, there will be side effects at the termination of the program. In this example, static int value is set equal to n. However, n is constantly changing. If you look outside of the block of code, it doesn't matter the order that the variables are called because the constant expression function will find this error before these values are even passed into it. This allows the side effects to not affect the end of the program termination.
One of the overarching goals of this proposal was to make C++ as a whole more novice-friendly and easier for beginners to pick up on and master, which is clearly evident in Mr. Stroustrup's quote on this slide. After concluding our research, we as a group decided that this proposal was overall beneficial for the language of C++. It simplifies the language and allows for a more natural combination of functions, and things just flow better. So you may be wondering what this means for the future of C++. First and foremost, future updates will make it less prone to error while simultaneously making it easier for beginners to learn.